On the most basic level, human beings are made up of 5 major components. 1. A body structure. 2. A muscle system to move the body structure free. A sensory system that receives information about the body and the surrounding environment. 4. A power source to activate the muscles and senses. 5. A brain system that processes sensory information and tells the muscles what to do. Of course, we also have some intangible attributes, such as intelligence and morality, but on the sheer physical level, the list above about covers it. A robot is made up of the very same components. A typical robot has a movable physical structure, a motor of some sort, a sensor system, a power supply and a computer, brain, that controls all of these elements. Essentially, robots are man-made versions of animal life. They are machines that replicate human and animal behavior. In this article, we'll explore the basic concept of robotics and find out how robots do what they do. Joseph Engelberger, a pioneer in industrial robotics, once remarked, "I can't define a robot, but I know one when I see one." If you consider all the different machines people call robots, you can see that it's nearly impossible to come up with a comprehensive definition. Everybody has a different idea of what constitutes a robot. Point 1. Bomb diffusing robots. Point 2. Mindstorms, Lego's popular robotics kit. Point 3. Industrial robots, automated machines that work on assembly lines. All of these things are considered robots, at least by some people. The broadest definition around defines a robot as anything that a lot of people recognize as a robot. Most roboticists, people who build robots, use a more precise definition. They specify that robots have a reprogrammable brain, a computer, that moves a body. By this definition, robots are distinct from other movable machines, such as cars, because of their computer element. Many new cars do have an onboard computer, but it's only there to make small adjustments. You control most elements in the car directly by way of various mechanical devices. Robots are distinct from ordinary computers in their physical nature. Normal computers don't have a physical body attached to them. In the next section, we'll look at the major elements found in most robots today. The vast majority of robots do have several qualities in common. First of all, almost all robots have a movable body. Some only have motorized wheels, and others have dozens of movable segments, typically made of metal or plastic. Like the bones in your body, the individual segments are connected with joints. Robots spin wheels and pivot jointed segments with some sort of actuator. Some robots use electric motors and solenoids as actuators, some use a hydraulic system, and some use a pneumatic system, a system driven by compressed gases. Robots may use all these actuator types. A robot needs a power source to drive these actuators. Most robots either have a battery or plug into the wall. Hydraulic robots also need a pump to pressurize the hydraulic fluid, and pneumatic robots need an air compressor or compressed air tank. The actuators are all wired to an electrical circuit. The circuit powers electrical motors and solenoids directly, and it activates the hydraulic system by manipulating electrical valves. The valves determine the pressurized fluid's path through the machine. To move a hydraulic leg, for example, the robot's controller would open the valve leading from the fluid pump to a piston cylinder attached to that leg. The pressurized fluid would extend the piston, swiveling the leg forward. Typically, to move their segments in 2 directions, robots use pistons that can push both ways. The robot's computer controls everything attached to the circuit. To move the robot, the computer switches on all the necessary motors and valves. Most robots are reprogrammable. To change the robot's behavior, you simply write a new program to its computer. Not all robots have sensory systems, and few can see, hear, smell or taste. The most common robotic sense is the sense of movement, the robot's ability to monitor its motion. A standard design uses slotted wheels attached to the robot's joints. An LED on one side of the wheel shines a beam of light through the slots to a light sensor on the other side of the wheel. When the robot moves a particular joint, the slotted wheel turns. The slots break the light beam as the wheel spins. The light sensor reads the pattern of the flashing light and transmits the data to the computer. The computer can tell exactly how far the joint has swiveled based on this pattern. This is the same basic system used in computer mice. These are the basic nuts and bolts of robotics. Roboticists can combine these elements in an infinite number of ways to create robots of unlimited complexity. In the next section, we'll look at one of the most popular designs, the robotic arm.